Hello, scientists. It's Monday, February 22nd. You are learning about gravity today. Gravity is something that helps us to stay on Earth. So we're not floating around in the air and hitting the walls. And wouldn't that be kind of fun a little bit? But that's not what we need to do every day so that we can go to school. We'd have to have like lead shoes on just so we could walk around. So gravity helps us to stay on Earth, stay grounded. We're going to watch a little video and then you're going to do a little bit of practice today with some reading and some activities. Let's take a listen. All right. Here we go.
Yet, but we feel its effects. It impacts everything in the universe. It's gravity. Come down to Earth and learn more.
We have to turn off the volume. Mine's check gravity.
Gravity is the force of action between two objects, in this case, between the melons and the Earth.
In the late 1600s, Sir Isaac Newton saw an apple fall from a tree. That made him wonder if the force that made the apple fall was the same force that kept the planets in orbit around the sun. Newton changed the way we all look at gravity.
To talk about gravity, you first have to talk about mass and matter. Now, matter takes up space and has mass. And mass is a measurement of how much matter something has. The more something weighs, the more mass it has, and the more gravity pulls on it.
But the Earth's gravitational pull is strong because it has so much mass. The greater the mass of the object, the greater the force of gravity. Astronauts could bounce easily on the moon because the moon's gravity is less than the Earth's, because the moon has less mass than the Earth.
Does that mean I weigh a different amount on different planets?
Well, on Earth, suppose you weigh 100 pounds. If you were on the moon, you'd weigh about 17 pounds. But if you were on a bigger planet, say Jupiter, you'd weigh more than a whopping 236 pounds. And gravity's effect depends upon how close objects are to one another. The Earth's gravitational pull on, say, Pluto isn't very strong because Pluto is so far away. But the Earth's gravitational pull on the moon is great. The Earth's gravity keeps the moon in orbit.
So if Earth's gravity is so strong, how do astronauts get into space? And why do they just float there?
Astronauts can take off from the Earth because the thrust exerted by the power of the rocket is greater than the force of gravity pulling them down. But astronauts never travel beyond the Earth's gravitational pull, and they aren't actually really floating. They are, in fact, always falling toward Earth. But since they're also moving forward, they fall around the Earth in a circle or an orbit. To the astronauts, this constant state of falling just feels like floating. It's called a state of weightlessness or zero gravity. These Boise State University engineering students are flying in a special airplane that can create moments of weightlessness.
Zero G.
They're studying the effects of microgravity on the traction of different wheel tread designs on lunar soil. And they're also testing ways to find out how much water there is in the soil on the moon or other planets.
Best feeling in the world, man.
Gravity affects everything on Earth, including the Earth. Gravity from the moon pulls at our oceans, causing high tide and low tide. Gravity pulls water from the clouds, causing rain and snow. Gravity tugs at rocks, causing simple loose rocks to move or whole hillsides to slide down. Even stars and planets are formed when gravity pulls dust and other small particles together. So gravity is one of the fundamental forces in nature.
Oops.
You okay?
Yep. What goes up must come down. It's just gravity.
If you want to learn more about gravity and other scientific topics, check out the Science Trek website. You'll find it at idahoptv.org/sciencetrek.
Okay, well that was fun for me. What you have to do today for your activity is to read a little bit more about gravity. Let me show you the screen for that. All right, so we're clicking on this. We're going to watch this video and then do slides 2 and 6 and read over slides 3 through 5. All right. So why do we stay on the ground? Lesson 5. Why do we stay on the ground? Slide 2, you need to drag the arrows to show the direction that rain would fall from each of the clouds. This is Mr. Earth. And then which way would these clouds, would the rain fall? And you can move them around. See this little dot here? You can move it sideways. You can use as many of the arrows as you need to. You just slide them over to show how the rain would fall. So there's many of these different arrows if you need a different one. So this is just a quick guess. Then let's read about gravity. You can click here to listen, or you can read it to yourself. And then here, again, his name is Isaac Newton, who they were talking about in the video. And another slide here of reading. Again, you can listen to it or read it. This one has 6 words on the side here, and you need to slide them over to where they belong in the sentence. So for example, number 1 says gravity is a blank. Gravity is a gravity? No, I don't think so. Gravity is an energy? Maybe. Gravity is an invisible force? Maybe. So those might be my only possibilities. So if I have to, I'm going to go back and reread because that's what good readers do. Gravity is, it says right here, gravity is an invisible force that pulls 2 objects together. Gravity is an invisible force, excuse me. All right, so just drag those over. And again, it doesn't take but 2 minutes, maybe at the most, to go back and reread if you have to find the answers for that. Okay, and then we'll continue more about gravity tomorrow. Thanks for watching. I'll see you later.